how did the density change on this one? Because this doesn't look like this, does it? So how did the density change?
Got denser.
Okay, so the lung moved to
Water.
water. And what's the distribution? Because the first thing is, how did the density change? Second is distribution.
Unilateral.
Mine is
local.
unilateral.
This is unilateral localized, isn't it? So the considerations are CATPE, consolidation, atelectasis, tumor, something in the pleural space, or something on the external chest wall. CATP. The fact that it's silhouetting the internal chest wall and the upper mediastinum tells us it has to be internal, which means E's gone. Because it can't be on the external chest wall and silhouette the internal chest wall. Can't work like that. So E's gone. This is not a configuration for plural, so P's gone. So we're down to cat, right? Now, what's this?
Fisher.
Minor Fisher.
Yeah, we know there's a well-defined, horizontally oriented boundary in the right lung, but not there, right? Down here, yeah, but not up here. So this is opaque all the way to the apex. From the chest wall to the mediastinum, it terminates inferiorly with a well-defined curvilinear boundary. Yes? Well-defined, curvilinear. Curvilinear just means it's a curve and it's linear. So, and it's running obliquely downward from the upper right lateral chest wall down toward the hilus, representing the displaced minor fissure. Okay, you can have that kind of density from atelectasis, you can have that kind of density from consolidation, but only one of them moves the fissure, right? So we know the fissure should be down here, now it's up here. So it has to be a volume loss, doesn't it?
Yep.
Because the fissure's moving toward the increase in density, and that's the number one direct sign, isn't it? Number one direct sign. On the lateral view, there's the upper part of the major, it should be back here. Now this, you see how this is a gradient density? It's not a nice, clear, distinct line. Why? Because this is on an oblique angle and the beam's hitting it this way, not this way. So it hits it on an oblique angle, so it looks like a gradient density, not a well-defined line like that. It's seeing the major fissure parallel, but it's not seeing the minor parallel to it. So that's why we have a gradient density. But the minor should be here, it's now here. Major should be here, it's now here. So they're going like this. It's a collapsed what?
A right upper lobe.
Where's the obstruction? Where's the obstruction? The obstruction is in whatever's feeding the lung that's collapsed. So what's feeding the right upper lobe? Right upper lobe bronchus. It's not the main stem bronchus. It's not the middle lobe bronchus. It's not the lower lobe bronchus. It's the right upper lobe bronchus, isn't it? So we know exactly where the obstruction is. Exactly where it is from the x-ray. And would you say this moved slightly? Yeah. Hilus, I don't think the hilus moved all that much. There may be a slight decrease in the rib interspaces. We can't see the trachea all that well. I'll bet the trachea is probably shifted slightly. But most of this seems to be overinflation and the diaphragm came up some. All the compensatory findings do not have to be there. There may only be one or two of them. They don't all have to be there.